Hi, my name is Zach,
And I'm Yuhan.
and this is the Swell Surf Foot, a low-cost, waterproof prosthetic with increased ankle mobility to encourage correct surfing mechanics. Later this year, the 2020 Olympics will introduce surfing to a new audience. Behind the scenes, the International Surfing Association is working on a plan to bring adaptive surfing to the 2024 Olympics. With this new wave of surfers, more people will be engaged in the sport than ever before. Ankle mobility is important, and most of the time it goes unnoticed, but not for those without a limb. Almost all the prosthetics on the market integrate planar and dorsiflexion motion, but the affordable, waterproof ones lack abduction and adduction. Abduction and adduction are pretty important in any type of balancing act, especially surfing.
We observed many empty surfers from the West Coast and noticed current feet they have don't adapt to the sports as well as they should. It is difficult to balance on the board when surfing because of lack of adduction foot motion, and very little flexion to the toe and grip on the bottom makes it impossible to do proper pop-up. The current prosthetic feet available on the market are either too expensive or don't adapt to the sport they're participating in. Empty surfer Raymond Ramos says that being in the water is the only time I truly feel limited as empty. After we talked to many empty surfers, we were able to define a design criteria based on their problems and needs. Swell needs to provide a larger range of motion in the ankle, has the ability to perform a proper pop-up without slipping, and is resistant to salt water and sand.
Meet the Swell Surf Foot. Swell is designed for surfing. With its unique dual bushing system inspired by skateboard bushings, Swells allows for a large 360-degree range of motion emulating the human ankle. The front of Swell flexes, just like the toes of a foot. It's flexible enough to perform a pop-up, but rigid enough to bounce right back. Swell is pocket-free. Unlike existing feet on the market, Swell won't pool with water or sand once it's in the ocean. This makes cleaning super easy and draining not a problem at all. Swell is made from a stiff polyurethane. Besides providing the necessary properties to bend and flex, it is both saltwater resistant and easy to wipe down.
Let's get ready to surf. First, arrive at the beach. Switch to your beach leg, then walk across the sand. We tested plantar flexion and dorsiflexion with the local empty surfer lens by walking on the treadmill. Our first working model was assembled with 2 rubber balls, rods, and wooden plates. From this testing, we located the point of flexion. To simulate the natural movement of the forefoot, we explored leaving hinges. After a couple failures on version 2, we decided to use a rubber material. It was flexible enough to smooth the movement and stiff enough to support the movement. After several testings, version 2 showed too much abduction and adduction motion. The separation of the bushings and so also created a tripping hazard. We attached the bushings and so on version 3 and pushed the bushings forward on version 4 to get the right amount of flexion.
Entering the ocean's next. You go out, paddle, and search for a wave. And if you're lucky, you get to shred some. The abduction and adduction motions were crucial to Swell's success. Through observation and testing, we set minimum angles that Swell needed to hit when moving side to side. Our first verification of this was when we tested with Lance, a local amputee, using a balance board, which is an exercise device many surfers use to practice and enhance their balance. Once we verified that the dual bushing mechanism functioned as intended, we began exploring the range of motion through the shape of the bushings. After testing variations of the shape, we landed between 2 shapes, the squish and the bulb. When we put them face to face, the squish outperformed the bulb.
The pop-up is a crucial maneuver to riding a wave. For the pop-up, first, paddle into position. Prepare to jump. push up and stick the landing. After observing different styles are popping up, we defined a range of degrees that swell needs to achieve. We made a couple prototypes and revisions from too much flexion to just enough and tested on empty surface lengths. After finishing the pop-up, here are two stances, regular and goofy, and we tested the key angles with the prototype.
The current model flexes enough forward, back, left, and right, successfully combining the previous efforts. The model we are using for tested is comprised of several different materials. An ABS printed top shell, a universal pyramid adapter that is attached to the ABS shell. The sole is cast from Smooth-On's Simpac 60A, which is 60A on the shore hardness scale. The treads are cast from Smooth-On's Dragonskin 30, which is 30A on the shore hardness scale.
We talked to Adam Discavage, material engineer and specialist at NOL for the materials and manufacturing. The bushings will be made from polyether-based TPU in shore hardness of 60A. The treads will be made from a polyether-based TPU with a shore hardness of 30A. The bushings and treads will be insert molded into the sole, which is made from the same polyether-based TPU with a shore hardness of 60A. Since all of the materials are the same, a molecular bond will be formed sealing the parts. The top shell will be injection molded from either polypropylene or Durin. Both materials are resistant to saltwater conditions, and we are currently exploring manufacturing costs. What's inside? On the very top is insert molded stainless steel pyramid mount connector to connect the pylon. 5 Type 316 hex head cap stainless steel screws to attach the rubber hardware cover to the top shell. 2 high torque 12-point flange nuts. 2 Type 316 stainless steel washers. And 2 titanium hex head screws that are molded with a plate into the sole and bushings and attached to the top. Injection molded ultra high molecular weight polyethylene plate that holds the screws in place.
Marked by the swell icon, individuals have the ability to adjust the stiffness of the bushings by opening the top. Peeling up the seal reveals 5 hex screws, the same that are used on the pylon. The rubber cover easily detaches to open the top with the included tool. Twist to the left to make it looser, and twist to the right to make it tighter. The rubber overmold doubles as an O-ring to seal the shell and keep the hardware from rusting.
The bottom shape of swell is a combination of the footprint from left and right foot. It has slab sides for enhanced tilt, large surface area for grip, and the scale is based on the average men's and women's shoe size. We explored treads for the grip, and this is the version 1 we molded and tested on empty surface lengths.
After testing with Lance, he said, "The material for grip helps a lot, but it feels a little unbalanced. Try moving it to the side and the front of the foot." So we went back to the drawing board and explored several different tread variations. We settled on an asymmetric design that covered the region mentioned by Lance and evoked the feeling of fluidity, like the ocean. Our testing validated that swell has potential. In the coming months, we hope to test with several amputee surfers themselves and gain further insights into how the foot can be improved. With several contacts scattered across the US as well as the globe, we see this as a real possibility. Additionally, we plan to explore the various options pertaining to intellectual property, manufacturing, and distribution. Swell is a lifestyle product, not a medical device. We want individuals with amputations to be inspired to surf and know that they can buy performance equipment just as easy as buying a pair of shoes. Now I think it's time to go catch some waves. Thank you.